So hello everyone, welcome to the channel. So in this video, I'm going to show you how to create a NDWI image in Google Earth Engine. So now let's get started. So NDWI is Normalized Difference Water Index. So now let me explain about this. So general description is NDWI is used to monitor a change related to the water content in water body. As a water body strongly absorbs the light invisible to infrared electromagnetic spectrum, the NDWI uses green and near infrared bands to highlight the water bodies. It is sensitive to build-up lands and can result in overestimation of water bodies. The index so as follows here. So we're going to use the Landsat 8 image for this. So for Landsat 8 to calculate NDWI, we're going to use band 3 minus band 5 divided by band 3 plus band 5. So the value description is the index value is greater than 0.5 usually corresponds to the water bodies, and vegetation usually corresponds to much smaller values, and build-up areas to the values between 0 and 0.2. So this is how we can able to detect the water bodies using this particular band ratioing, that is normalized difference water index. So now let me get back to our Earth engine. So first we need to create a study area for this particular to find the word normalized different water index for any study area. So for that we had to define a study area. So we can able to see that this is an option called draw a rectangle. So you can click this option here and you can draw a rectangle over this any part of the study area of your choice to create a normalized difference water index. So now I have already created here. I just click this option and draw a rectangle over this study area. So once you did that, we're gonna import our Landsat 8 image into Earth Engine. So for that, we defined a variable called L8. Variable called L8 equals to w.image collection Landsat LC08 collection to tire top of the atmosphere. And to get the least cloud contaminated image, we defined a variable called variable image 2023 equals to w.image and L8 dot filter bound point. So the point here refers to our study area polygon here. So polygon 4 vertices. So this is our polygon with 4 vertices. And next is we're gonna navigate here. That is L8 is dot filter bound point refers to study area, and we're gonna specify with for a specific time period. For that, we're gonna use dot filter date 2023 January 1, 2023 December 31st, and we're gonna sort with the cloud cover. So least to get a least contaminated cloud, we're gonna define dot sort cloud cover, and first function here represents the image. The least contaminated image will be available using this particular option here, first function. So we get a Landsat 8 image of least cloud contaminated. And next, to visualize the result of this particular image, we define print image 2023 dot float function. And next, to compute our normalized difference water index using Landsat 8 image, we defined a variable called b3 image 2023 dot select b3. So next we're gonna select we're gonna create another variable called b5 equals to image 2023 dot select b5. So from Landsat 8 image of we're gonna use these two bands, band 3 and band 5, to calculate the normalized difference water index. So now we created a variable b3 and b4 referring to and we're selecting this band 3 and band 5 from our Landsat 8 image. So now to compute the normalized difference water index, we define variable. So now to compute our normalized difference water index, we defined a variable called NDWI 2023 equals to B3 dot subtract B5 dot divide B3 add B5, and we're gonna rename as this. So we're gonna rename as NDWI, that is normalized difference water index. And now, now to display the result, we define map.center object image 2023 with a zoom level of 9, and a variable NDWI params. We have to define a visualization parameter. So for that, we defined NDWI params equals to, we set a minimum of -1 and to a maximum of +1. And color palette we are using is green, yellow, and red. So red are the areas. So red are the areas where highlights the water bodies. So we can able to see from this image here. Let me show you at the last here. So after that, we're going to navigate to create a variable called visparams_true for which true visualization parameter for true color composite of Landsat 8 image. So for that, we define this variable. This variable called visparams_true equals to band B4, B3, and B2 referring to true color composite. We set a minimum value of 0 and to a maximum value of 3000 and a gamma value of around 1.4. So now to add this layer into our Earth engine, we define map.addLayer NDWI 2023, and NDWI params refers to a visualization parameter for NDWI image, which is represented here, the NDWI params, and output the layer name as NDWI image 2023. And last, to add our true color composite, that is Landsat 8 image into our Earth engine, we defined image 2023 with params true and Landsat 8 image false. So now to let us run this code and visualize the result here. So we're going to click this option called run and click run. So this is our study area polygon here. So we're going to visualize the result here. So now let me turn off this polygon here. So you can able to visualize from the image here. So all the water bodies or areas are clearly indicated in red color. So non-water bodies areas been indicated in this set of color here. That is we have defined earlier as this particular set of colors, that is green, yellow or not water bodies, and red indicates the areas where the water bodies. So you can able to see from this image here. So this is the Brahmaputra river here. You can able to clearly visualize the result. All the water bodies of this particular river has been clearly identified in this image here. We can able to see here, and also the nearby lakes also been indicated here, the water bodies. And at last, to visualize the property of this Landsat 8 image, we have to navigate to this console section here. In that, this details about this image is given here. We can able to see there is a band property of 17 elements, and you can able to visualize the properties here, the different metadatas of this Landsat 8 image. You can able to go through this. There is a lot of metadata for this particular Landsat 8 image is given here. So now in this video I have shown you how to create NDWI, that is Normalized Difference Water Index image in Google Earth Engine using Landsat 8 image. So thanks for watching, and subscribe to our channel and give us a like.